Hello. Now we are going to look at an explanation for the steps in algebraic long division. Now up front, this is not a method I recommend you actually use for solving problems. The purpose of this is to make the steps divide, multiply, subtract, and bring down that we use in formal long division, these question setups here. Where do these steps come from? What is actually motivating those steps? To understand that is our goal in this video, not to look at a method that you are likely to use in practice. This method will work, but there are generally easier ways to solve the problems. This is simply to understand where do these strange businesses of divide, multiply, subtract, and bring down actually come from. And where they come from is factorizing. So this is a way of approaching factorizing so that we can cancel out common factors top and bottom in a fraction, because division and fractions are really the same thing. So if we start out with a relatively simple fraction here, we have 10mk divided by 5m. Well, we may be able to immediately see we have a common factor of 5m top and bottom. What we're going to do is write that out. So we're going to have 5m multiplied by what would give us 10mk? Well, 5m. So we take what we're trying to divide in, we write it down, and we say, what would I have to multiply that by to end up with 10mk? Well, I'd have to multiply 5 by 2 would be 10, and mk, well, m times k would give me mk. So that's 2k, all divided by 5m. Now the trick that we always use when we are simplifying fractions or doing division, or simplifying a fraction, is that we say this is essentially the same as fraction multiply gone in reverse, as factorizing often is doing multiply in reverse. So I can say that the bottom line is 5m times 1, and this essentially means that I have the fraction 5m divided by 5m multiplied by 2k all over 1. I essentially have those two fractions multiplied together. 5m divided by 5m is just 1, and 2k all over 1 is just 2k. So that's going to be 1 multiplied by 2k, which we tend to write as 2k. Fundamentally, that's where all of the rest of this is going to come from. We're going to write the top line in terms of the factor that is the bottom line, and then we are going to divide above and below by this common factor, simplifies to 1, and that leaves us with the remaining factor on the top line. Let's do this with a slightly more complicated one. So we have 18x squared minus 12x divided by 6x. Can I write both of these terms in terms of 6x? So I'll write my first term 6x times what would give me 18x squared would be times 3x plus 6x times what would give me minus 12x. That would be minus 2. That's still all over 6x. So I can write this as 6x all multiplied by 3x minus 2 all over 6x. And then I can say 6x divided by 6x is 1, and I'm left with 3x minus 2. Again, if I have a more complicated denominator here, what I'm going to do is take the highest powered term here, the first term I've got here, the 2x, and see how many times that would go into 14x, and see if that works out for how many times this would go into 5. So 2x goes into 14x 7 times, so I'd have 2x multiplied by 7 is my 14x, and I want to end up multiplying my minus 5 by the same thing. So I'll write that in there, minus 5 multiplied by 7. So I tried 2x divides into 14x 7 times, and then I saw that I also have the second term would be 7 times the same factor times the minus 5. So the top line can be written in terms of the bottom line by taking out a common factor of 7. Oops, that's all over 2x plus minus 5. And then we can divide above and below by 2x minus 5, or this divided into itself once leaves me with 7 times 1 is 7. Now that we have our factorizing discussed, let's have a look at the steps in long division as an example. So what do I do when I want to do this long division? I take the highest power here and I divide it into the highest power here. Very similar to what I did here. 2x went into the highest power here. So that's where my division first comes in. 4x divided into 8x squared goes in 2x times. Then multiply 2x times 2x times 4x is 8x squared. 2x times 3 is 6x. And now I want to subtract. You may notice that's again what I had here. 2x times 7, 2x times, minus 5 times 7. That's where that multiply line comes in. Then I subtract. That doesn't come up just here, but it will in just a minute. And I end up with 28x, and then bring down 21. Repeat the whole cycle again. 4x goes into 28x 7 times. Multiply, we get 28x plus 21, and subtract, and everything sums to 0. So those are our steps. Now if we write the same question, this is an identical question just written as a fraction, what we need to do to mimic what we've already done on this simpler factorization method is we need to write this top quadratic as 4x plus 3 times something else, times some other bracket. And because I know how stuff multiplies out, I know it's going to be some number times x plus some number is going to be what's in the second bracket. Now I already know it's 2x plus 7 is what's going to end up in this bracket because we already did it using long division. So to make this work, to be able to simplify this out and be left with 2x plus 7 from our division, we have to be able to write everything on the top line, factorize this such that we end up with 4x plus 3 multiplied by something. Well, the preceding line to this must have been 4x plus 3 multiplied by ax plus 4x plus 3 multiplied by b. Now, let's see if we can figure out how to use these steps to get there. So we start off, as we did before, our highest power here divided into our highest power here. So 4x divided into 8x squared. So I can write 8x squared as 4x times 2x. And I know that I want to end up with the same thing times 3. So I'm just going to write that in. I want to end up with plus 3 times the same constant. So I can factorize it like this in a minute. But I can't just add something onto my line because that would change the quadratic. So what I have to do at the same time is take away the same amount. So I'm adding this and taking it away at the same time so that I'm not changing my quadratic. This is a trick we use in quadratics from time to time to change them, to change their appearance in useful ways. So that's what I've got so far. So I can now see these two terms here. I can take out the common factor of 2x and I'll be left with 2x times 4x plus 3. That will have gotten me closer to my situation here, writing everything in terms of, everything on the top line in terms of 4x plus 3. Another way to look at this step of subtracting is if we're removing this 6x here, so 3 by 2x is 6x, if we're removing this 6x here, it must be removed from this 34x here. That would be an implicit way of doing this step where we're adding and subtracting. So if we take a look at what we've done, we said 4x goes into 8x squared 2x times. So I wanted to have, I divided in, then I multiplied by my 2x. I wanted it to have 4x by 2x. That's my factorizing my 8x squared. And I wanted to have 6 of these x's here taken off as 3 by 2x. So this was the divide, then the multiply step. And the subtraction comes from the fact that I've taken this 6x away from my total pool of 34x's here. Now I'm doing that subtraction. Now we are essentially onto bringing it down. We're now going to do exactly the same steps with 28x plus 21. So 4x into 28x. Well, I can rewrite this as 4x times 7. And can I write 21 as 7 times 3? Well, I can. 21 is 7 times 3. So it's going to be plus 3 times 7. Oh, I've missed the first part of my fraction, so I'll rewrite that. Now we've gotten to the stage where we have taken out my common factor of 7 here. So now I have 4x plus 3 times 2x plus 4x plus 3 times 7. So I can take out this common factor of 4x plus 3 from all of the top line. And now I have 4x plus 3 as a common factor top and bottom. So 4x plus 3 divided by 4x plus 3 is 1, and I'm left with 2x plus 7. And that is where all of our steps in the long division come from. We divided in and used that to factorize our 8x squared. And then we said, well, we want to have this factor times 3 so that we can factorize it like this. So we said we must have 3 times the 2x that we had here. That allows us to factorize our steps. So we had our divide, multiply, our subtract to keep everything the same. If I add this on, I must subtract this away so that I'm effectively just adding 0. That's my subtraction step. And then the bring down is essentially, I've gone through that cycle. Now I need to do it with the second half of my top line of my fraction. Now I encourage you to take a moment and try and do the same steps here. Maybe do the long division first, and then see if you can follow the same steps to complete out the division using this factorizing method for this. And I'm going to write out those steps, but pause the video and give it a go. So we divide 5x into 15x squared, and we say, well, I can write this 15x squared as 5x times 3x, and I want to have 2 times the same factor, so I say I'm going to have plus 2 times 3x. Well, to keep this equation the same, or this expression the same, I have to subtract the same amount, so I'm not changing everything overall. So I end up with doing my divide, multiply, subtract, and now I need to tidy up. Now I've done my subtraction, I'm back to being, I have my first part of my fraction, or my top line of my fraction, written in terms of my factor on the bottom. Now can I do the same thing for my second one? This one's actually fairly straightforward. I can see it's just a common factor of 1, but we'll do it step by step. So 5x into 5x, well, I can write 5x as 5x by 1, and so on. Now I have both of the terms on the top line written in terms of my bottom factor, my 5x plus 2. So now I can take out that common factor of 5x plus 2, so that the whole of the top line is multiplied by 5x plus 2. Taking out that common factor, effectively doing our fraction multiplication in reverse, we can say that this is essentially the same as having the fraction 5x plus 2 all over 5x plus 2 multiplied by the fraction 3x plus 1 all over 1, which simplifies, because this just goes into itself once, simplifies to 3x plus 1. And that's where all of our steps in long division come from. Just for completeness, we're going to check our answer by doing it out the normal long division way. And we find that we get the same answer. As I said at the beginning, the purpose of this exercise is not to give a method that is likely to be the one you use for solving these problems, though it's a perfectly valid method to use. The purpose is to see the fact that these strange steps, these apparently arbitrary steps that we use in algebraic long division, are really just a way of creating a mechanism that does the steps of this factorizing method for us. That's fundamentally all that's going on with these strange steps of divide, multiply, subtract, and bring down. And that's what we need for now.